In this video, I'm going to talk about updating row data in a Grid. Now, this is not editing data. Editing data is when the user manipulates the data using the Grid's UI. This is about the application updating the display data in the grid. So this includes inserting rows, removing rows, or just simply refreshing rows. I'm going to use this basic grid application in front of us here. You can see on the right hand side, I'm showing a list of cars. I've defined the columns here. I'm showing a type, year, color, and price. Here I've defined our grid component, and then the row data is up here, and I'm initializing it with a list of cars. The price column has a value formatter. I've defined the formatter up here. It just simply uses the $sign and puts in some commas. And then the cars here that I'm using to initialize the row data state comes from here, where I'm initializing an array of 4, and then I'm using create one car record method, which is coming from this file here. This is just a utility function for creating one car record for this example. In my other videos, I typically load data from the server, but in this video, I want to manipulate the data. I want to be adding, removing rows, etc. So I want to keep the data close. That's why I'm not taking it from a server. Let's start with inserting a button to insert one record at the start of our dataset. This is the button down here, and when I click on it, this callback is called it creates one new record using my create one car record utility function. It creates a new list, adding the new record at the start, and then it uses the hook set row data. Let's see when we hit it, does it work? Yes, it does. Okay, so I half like this. It's working, but it's a bit meh. Let me show you why. What we need to do is enable some row selection. Here I've set row selection to multiple. So now on my demo, if I select 2 rows, they're now selected by the grid. However, if I hit insert one now, click, the selection is lost. So the grid hasn't maintained selection between updates of the row data. This is because the grid has no way of matching rows from the previous set into the new set, and that is fixed by providing row IDs to the grid so that it can match rows. This is a bit similar to the key attribute that you'd normally use in React when rendering lists. So down here I'm using the getRowID grid property, and I'm passing it this method here, which I've used the useCallback hook. It takes params and it should return back the ID. Now the params I'm just printing to the console so we can take a look over here and see what's inside the params. We've been provided with the Grid API and Column API, but also the data. That's the data item in our row data. So for this example, that is my car information. And here I'm returning back the ID of the car, which is a unique ID identifying that row. The last 2 items here, level and parent keys, are only used when you're using the server-side row model and grouping. Okay, so let's test. I'll select 2 rows as before and hit insert 1. Perfect. The selection remains, but you will also notice that the rows are now animating. That wasn't the case before. The reason why they're animating now is the grid is able to work out, oh, this row, that was there before. Rather than destroy the row and recreate it, I'm just going to move it down, and it provides a nice, smooth transition. Animate rows is enabled using the grid property animate rows that I've set down here. And this was set since the start of the demo, but it'll only work with updates after you've provided row IDs. Okay, let's now talk about row order. To help with this, I'm going to implement another button which will reverse the order of the provided row data. I'm also going to enable sorting on the first column. This is the new button down here. It's called reverse. When it's clicked, this function here gets called, and this function creates a copy of the cars list and reverses it and then sets it as the row data. I can then demo this by clicking on reverse here, and you can see that the rows are being reversed. So the order of the rows in the grid will always match the row data order that you provided here, unless you're sorting in the grid. And here I've enabled sorting on the first column, the type column. So if I sort here, now if I reverse the order, it makes no difference because the grid is applying an order to the rows. However, if I take sort off, then it goes back to matching the order in the row data. Right, that's row order. Now we've seen adding rows, now let's look at removing rows. I'm going to implement a new button called remove selected that will take all the selected rows from the grid and then create a new list of cars filtering out all of the selected rows and then set that as row data. Okay, the code is now all done. So down here I've got my new button, remove selected. It'll call this callback here. This line gets the selected nodes. Here I pull out all of the selected IDs, which is then used down here in my filter for the cars, and I'm excluding all of the cars whose IDs are in the list of selected rows. I then set row data. Now to demo, I'll pick the first 2 rows and hit remove selected. Perfect. So we've seen inserts and we've seen removes. Now let's look at updates. To do this, I'm going to create a new button called update sum, and this is going to take some of the data and update the prices. So here's the new button down here, update sum, calls this callback here. This callback will go through all of the cars, and here it's going to update half of the cars. So if this math.random is over 0.5, which will happen half of the time, it'll just return the car as is, meaning it won't update that row. Otherwise, it'll return a new object, the same as before, except the price will be replaced with the previous price plus this random number here. It's a random number between -1,000 and +1,000, so it'll nudge the price either up or down up to $1,000. Right, let's demo. I'll click on update sum, and you can see here on the price column that the values are getting updated for some of the rows every time I press it. Now it's a bit hard to see those updates. Wouldn't it be nice if the grid flashed the cells as a value changed? Well, that's done by setting the grid property enable cell change flash to true. Now in the grid, when I hit update sum, you can see that the cells are being flashed. Sweet. Wouldn't it be even cooler if the grid not just flashed a cell, but actually showed us what changed? That's possible using one of the grid's built-in cell renderers. Here I'm going to program in the animate show change cell renderer. So I've disabled the flashing down here. I've taken this line out, and then up on the column definition for the price column, I've now specified this cell renderer here. Now it's a string, which means the grid's going to look this cell renderer up, and the AG animate show change cell renderer is one of the cell renderers that comes with the grid out of the box. Now when I click on update some data, cool. So the grid is showing in red if the price is going down and by how much, and it's showing in green if the price is going up and by how much. We have now looked at inserts, removes and updates. For most applications, this is all you will need with regards to changing data inside the grid. It will perform brilliantly, most of the time. When I say most of the time, the one time you might want to consider doing something else is when you have large amounts of data. You see, when you provide row data to the grid, it has to work out which rows are new rows for inserting, which are old rows for removal, and which are the same for updating. This comparison of old row data and new row data takes time, and for large data sets, this time can lead to poor performance. For this reason, the grid has another mechanism for updating data called update transactions, and update transactions is what we're going to talk about now. Let's start with inserting using transactions. So I'll create a new button called txinsert1 and attach a listener to this button to insert the row using a transaction. So here's the new button txinsert1, listening to onTXinsert1. onTXinsert1 is up here. We create a new record just like we did before, but instead of manipulating the row data, we use the apply transaction method on the grid API. And the apply transaction method is taking what transactions to add as a list. Now if I click on the button up here, txinsert1, you can see that rows are being added. One thing to note here is that the grid data is now out of sync with the store. What I mean by that is I'm using this variable here to represent the store in my application, and it's this list which is provided into the use state for row data. So both my store of cars and row data still has the first 4 rows in it. It didn't get updated as I was applying transactions into the grid. So the grid is managing the row state, not the application. Now this isn't really an issue. You can always query the grid at any time to see what rows are inside the grid using the grid's API. So we are breaking away a bit from standard React patterns. The reason we're doing that is for performance. The grid will perform better with very large data sets if we use transactions for updates and let the grid manage the row data. Right, let's go back down to our transaction object. The apply transaction method takes an object. We call that object a transaction object, and it can have 3 attributes: add, remove, and update. In this method, we just used add, but we could have used the other two as well. All three take a list of row records. So that means in one transaction, you can add, update, or remove as many records as you like. The apply transaction method also returns back a result. So let's capture the result here and print it to the console. So I'll just refresh here, open up the console and hit insert 5 times. And you can see here that each time it's inserted, the result is printed. Now the result looks similar to a transaction. You've got arrays for add, remove and update. But what's inside the arrays isn't the row data, it's the row node associated with the row data. As you probably know at this stage, the grid wraps each data item with a row node object. And it's these row node objects that get returned inside the result for apply transaction. Okay, let's take these out of this method because they don't belong here and move on to the next piece, which is using transactions for updates. So let's write some more code. We'll put a button in for updating using transactions, and then we'll put a listener in. And once I've finished writing the code, I'll explain. Okay, so there's a new button and it calls this method here on txUpdate. This method ends up calling apply transaction with a list of records to update. This list of records starts off as an empty list. Then I loop through all of the rows in the grid using for each node. For each node is a grid API. It's a bit like for each in an array, where it'll call you back once for each record inside the grid. Now the record that it returns back is a row node, and we get the data from the data attribute of the row node. So that's where we get our car record from here. As with the other update, we'll skip half the records using the same mechanism of a mat.random greater than a half. And then here we create a new record and we push it onto our updated records. Again, changing the price by a random number up to $1,000 up or down. Right, does it work? It does. And the grid is still highlighting the changes. Brill. Okay, 2 points to note here. The first is I used the grid API to go through all the rows in the grid. I didn't do that with the previous update method. In the previous update method, I just used my local store of cars. However, remember, the local store is no longer in sync with the grid's rows if you're using transactions. Then the second point is with regards which records to update. When the grid is doing an update, it's able to match records based on row ID. And for that to work, we must provide the row ID callback, which you've already done. So a prerequisite of transactions to work is you've implemented a get row ID and given it to the grid. And then last but not least, remove using a transaction. So again, let's put in the button and let's put in a listener. This is the new listener for removing with a transaction. The first step that we do is get the selected nodes from the grid. We do that using the getSelectedNodes grid API. We then do a map on the selected nodes because you don't want row nodes, we want data items, which comes from the node.data. Then with the list of data items, we provide that to a transaction and say remove the selected data. Right, let's see if this works. Let's pick these two rows and hit tx remove. And it does some work. What happened here? Ah, yes, of course. It should be gridref.current.api. Right, retry. Select the first two rows and hit remove. Yay! Okay, we've now seen how to add, update and remove rows by updating row data, and we've seen how to add, update and remove rows using update transactions. That will cover 99.9% of all your requirements. However, there's probably 0.1% of you that have another requirement, and that is high frequency updates. And for that, we use asynchronous transactions. So when I say high frequency, I'm thinking maybe there's a WebSocket open, and coming down there's about maybe 10, 20, 30 updates per second. And if you were to apply those updates individually to the grid, well, each update would require the browser to refresh and repaint. And if you're trying to refresh or repaint a browser 20 or 30 times a second, well, it's not very possible. The browser will just come to a halt. In addition to that, if the grid is doing any processing, such as grouping or filtering or sorting, that would need to be done every time an update comes in. Again, more strain on the CPU. And that's where asynchronous transactions comes in a grid. It's a way of grouping updates together and applying them all in one go, almost like batching updates. So let me write some code and show you. So one more button and one more listener, and this listener will insert one record, this time using asynchronous transactions. So this is the code here for doing an asynchronous transaction insert. It's almost the same as doing just a standard transaction insert when we're not using asynchronous. The difference is this method here. When we're doing a standard transaction, we call apply transaction. When we're doing an asynchronous transaction, we call apply transaction async. Then when we click on this tx async insert one button, we can see that it does an insert. Now it inserts one record every time I press the button. It looks to be behaving the same as the previous inserts, but the difference here is whenever I do an insert, the grid is waiting 50 milliseconds before actually doing the insert. It's waiting to see if any more transactions come in, which it will apply in the same batch. Now as humans, we can't observe this. 50 milliseconds is too short. So for the purposes of this demonstration, I'm going to change the amount of time that the grid waits. And that's done using the grid property async transaction wait millis, which I'll set here to 5000 or 5 seconds. Now let's click that button again. Click 1 AG grid, 2 AG grid, 3 AG grid, 4 AG grid, 5 AG grid, and it inserted. Here's the record down here. Now that didn't do any batching because I only inserted one record. So let's insert a bunch. I'll click this a bunch of times. 1, 2, 3, 4, 5. 1 AG grid, 2 AG grid, 3 AG grid, 4 AG grid, 5 AG grid. Oh, and there we go. So these are the 5 rows here that the grid inserted. It waited for 500 milliseconds and then inserted all these records at the same time. I am now going to go back and put in code we had earlier to print the result of applying a standard transaction. And I am also going to put in the equivalent code for printing the result of an asynchronous transaction. Let's test this now on the right hand side. Open up the console and click 1, 2, 3, 4, 5. Oh, road, the Rockland bog, the bog down in them valley, oh, road, there we go. So as before, the result looks like a transaction, but instead of returning back data items, it returns back the row node, which is the object that the grid created to represent the node. So let's compare the code here between the asynchronous and the non-asynchronous way. With the non-asynchronous way, the result is just returned back from the apply transaction method. With the asynchronous way, you have to provide a callback to the apply transaction async, and this callback is called after the transaction is applied and it's provided with the result object. There's an event I want to tell you about, that is the async transactions flushed event. So I'm registering for the event down here, and then here's my event listener, and I'm just printing out the event to the console. So let's test. We'll hit this button a few times. Hit me baby one more time, I must confess, I still believe, and there we go. Okay, so these print statements down here, these 6 rows down here, we've seen them before. That's the result of the apply transaction async being printed to the console. The new bit is this top bit up here. That's the event that we've just caught. I'll open up the event so we can take a look, and I'm interested in the results attribute. Each object in the list here is the result of one transaction. So the objects are appearing twice. I see it once in the list here, and then they're also printed individually down here. So there are 2 ways of getting this result object. The first is the return type of the apply transaction async method, and the second is using the event. The first is best if you want to do something in response to an individual transaction getting applied. And the second, the event, that's best if you want to know when all transactions have been applied. Okay, there's only one more thing I want to show you in this video, and that is how to flush the transactions explicitly. So let me just code that up. So when I click on the flush button, this is the callback that's going to get called, and it's calling flush async transactions on the grid's API. I'll now click on insert one record, and I won't wait 5 seconds, I'll hit flush. And the record appeared as soon as I clicked on flush. Let's insert 3 records, 1, 2, 3, and now flush. And the 3 records appear as soon as I flush. And we're done! That was a lot of information in this video. We saw how to update data in the grid in a few different ways. We first looked at updating with row data, and this is great and will be what you do most of the time. Then we also looked at updating using transactions, which are better for large data sets. And then finally, we looked at asynchronous transactions, which are great for high frequency updates. It's time now for you to go and live the rest of your lives. I recommend maybe leaving your desk, going to the kitchen, getting a coffee, have some good water cooler chat, and maybe tell somebody about how great AG Grid is. Goodbye.